The fictional college aptitude test has scores that are normally distributed with a mean of 1,000 and a standard deviation of 200. Part A. What is the probability that a randomly selected student taking the CAT scores above 920? Okay, so key thing here is they've told us that this thing is normally distributed. So, knowing that, I'm going to draw a normal distribution. That's really the best way to begin any of these problems. Now, if you'll notice, I went ahead and drew my normal distribution so that the 1,000 was right down the center. And then I marked everything off by 200s. And I kind of estimated where 920 would be, and I've shaded to the right because I want the probability that the person scores above 920. So, to get a normal probability, I use the normal CDF function, but I go from my lower end point, which is 920, to my upper end point, which I don't really have a particular upper end point because it's just going on forever here. Just put in like 10,000 or something like that. That'll be fine. Something to be large enough to represent positive infinity. Next, I also need to input a mean and standard deviation. So just the mean of 1,000 and the standard deviation of 200 that was provided. So my answer here to part A is 0.6554. Part B, find P sub 65, the 65th percentile for the CAT scores, a score that separates the lower 65% of the data from the rest. 3 ways of saying the exact same thing. So let me draw a distribution, and I've just kind of, labeled it with the, mean of 1,000, marked everything off by 200, just so we have, a bit of a reference to go on. Now the idea is, I'm trying to estimate where the lower 65% of my data, is cut off. So for instance, I know from the mean, 50% is to the left, 50% is to the right. So if I'm looking for 65% to the left, it needs to be larger than that. So maybe it's, I don't know, right around here or so. I'm looking for just getting this to be, this area right over here that I'm kind of shading in as best I can, to be 65% of the data. Now, in order to calculate that specifically, other than just saying like, oh, it looks like, I don't know, 1,150, we can actually calculate that with the inverse norm function. So inverse norm takes 3 inputs that we're going to give it. It can just take 1, but we're going to use 3 here. The first is the area to the left of the score we want to find. The next is the mean of our distribution. And the last is the standard deviation of our distribution. So it calculates that for us and finds that the value we need is 1,077. Now, normally you round these things to the nearest, to the same accuracy as the given mean and standard deviation. But these are kind of funny since they're 1,000 and 200. Like, are they to the nearest 100, to the nearest 1,000, to the nearest integer, and it just happens to round off perfectly? Who knows? If you're unsure, just try and match it as best you can. I'm just going to go to the nearest integer just because I feel like that will be fine. Part C, if a random sample of 40 students is given the CAT, what's the probability that the sample mean of their test scores is below 1,070? Well, again, a good picture really helps out a lot in these. So let's draw a nice distribution. Okay, now, a couple of things that are different here. Number one, The mean is 1,000, but notice that I've marked off my standard deviations with not 200, but it looks like about 32. So the reason for that is when I'm working with a sample of 40, my standard deviation reduces by a factor of the square root of that sample size, which is about 32. So the 1070, I've just kind of estimated where it would be approximately, and I'm looking for the sample mean to be below that, so I'd be shading to the left. Which means when I go to do my normal CDF function, I'm going to give it, a value that's representing negative infinity, so negative 10,000, and then 1070, then the mean and standard deviation. So the mean is still 1,000, but now the standard deviation has changed. It's now 200 divided by the square root of 40. So I'm not going to, oops, what did I do there? Let me get that right. Square root of 40. Okay, so I'm not going to just type in approximately 32 for here because I want it to be as accurate as possible. So it's going to come up with this, the calculator is going to come up with as a result, save it with as many decimals as possible, and not round anything until the very final answer. And that way I'll just get the most accurate result as I can. So this probability here is 0.9866 when I round to 4 decimals.